So here is an example for testing P. Team of eye surgeons has developed a new technique for a risky eye operation to restore the sight of people blinded from a certain disease. Under the old method, it is known that only 30% of the patients who undergo this operation recover their eyesight. All right. Suppose that surgeons in various hospitals, so this is 30% is, by the way, previous knowledge. So right now, our surgeons in various hospitals have performed a total of 225 operations. So that is your sample size, and that 88 have been successful. That is, patients fully recovered their sight. Can we justify the claim that the new method is better than the old one? Use a 1% level of significance. Okay. Establish H0 and H1. Level of significance is alpha 0.01. P be the probability that a patient fully recovers. Null hypothesis is that P is 0.30. That's 30%. So null hypothesis is P 0.30. The alternate hypothesis is that the new method has improved the chances. That is, H1 is P greater than 30%, greater than 0.30. Now, we need to check our requirements. Is the sample sufficiently large? Well, we had, so let's, and then once you recognize that, find the sample test statistic P hat and convert it to a Z value. All right. How do I know whether the sample is sufficiently large? Look for N times P. You multiply it. Is that greater than 5? Yes. N times Q. P is 0.3, so Q is 1 minus 0.3, that is 0.7. Is that bigger than 5? Yes. So now we can use our sample statistic P hat, that is R over N, that's approximately 0.39. The Z value corresponding to P hat is given by this formula. P hat minus P over square root PQ over N. That is approximately 0.39 minus 0.30 all over square root of this object. Z comes to approximately 2.95. In the formula, the value for P is 30%. That was from the null hypothesis. And Q is 1 minus P, so that is 70% or 0.70. All right. Now, you got statistic Z, the standardized value to be 2.95. The P value for this test statistic, okay, you want to be greater than this. So you're looking at the right tail. You want area, the P value is the area to the right of Z equals 2.95. Well, you can use your table, and that comes to approximately 0.0016. Now that P value is smaller than 0.01. So we are able to reject the null hypothesis. What is the interpretation? At 1% level of significance, the evidence shows that the population probability of success for the new surgery technique is higher than that of the old technique. In other words, we are able to reject the old standing probability being 30%. Now we can assume that the the probability of success is more than 30%. Okay. All right, so that completes section 9.3. Next videos will cover problems on 9.3. Until then,